Hey everyone, so today is going to be a lesson on learning more about solving trigonometric equations. If you haven't already done so, get those video notes printed out, and you should have already done this Desmos activity. If you haven't already done that, stop the video, do that first, and then come back and do this, okay? All right, so then part 2 is to just practice how to solve trigonometric equations on a very specific interval. So our interval pretty much focuses on the interval from 0 to 2 pi. Okay, so there we are. It doesn't mean that you always are going to be solving trig equations between 0 and 2 pi, but the good news is that if it's not, then you can just add on whatever you need to get into the interval that you want. Okay, so when we go to solve these, the first thing you want to do is get the trig function by itself. So I'm going to start by adding 1, and then I'm going to divide by 2. And then once I have the trig function by itself, I am going to kind of ignore that middle piece of it. So just think about let's see, let me get a different color. Just kind of don't look at that for right now. We're going to look at it in a minute, but don't look at it right now. And you just want to know, when is sine equal to a half? Or where does sine equal a half? Well, sine is equal to a half at pi over 6 and 5 pi over 6. Now I go back and use that thing that I cross off in the middle, because that's the angle that we're talking about. So sine is equal to half at pi over 6 and 5 pi over 6. And the angle in the inside that we're thinking might do that is then 2 times theta, not just theta. So we're going to set each of these two things that we found equal to theta, equal to 2 theta. And then we're going to solve for theta. So this becomes pi over 12, and this becomes 5 pi over 12. And if you remember from the Desmos, what you should have seen is that when you make the period smaller, because the period of this graph is now equal to 2 pi over 2, so when you make the period smaller, you get more answers, and you actually get more answers by a multiple of whatever number is inside here. So we should get twice as many answers as we would have expected. So normally between 0 and 2 pi, sine is equal to a half twice. Now we should get 4 answers where that would happen. Here are the first 2. To get the next 2, you're just going to add this period onto the problem, or onto your answers. So we're going to add pi here, and we're going to add pi here. Well, we're adding 12 pi over 12 on, so the next answer is 13 pi over 12. And the next answer on this side will be 12 pi over 12 plus 5 pi over 12 is 17 pi over 12. So there are 4 answers. Here they all are. Sometimes students get confused on trying to determine when to stop adding the period onto the problem. So let's say you couldn't remember that there's probably 4 answers. Then what you can do is you just take that period and you add it on again. So if I were to add pi on again to this answer here, I now add 12 pi over 12, you get 25 pi over 12, which is greater than 2 pi. 2 pi would be 24 pi over 12. So this is bigger than that. So that means this doesn't work because it's not within this interval that we were working in. And the same thing will happen over here if I add 12 pi over 12 onto this part. So that's a good check. You can keep going and then just cross off the ones that you know aren't going to work. Okay, next problem. So now a couple more steps are going to be added to this one, but still should be okay. So I get cosine of 3 theta, minus pi over 6. Left off my 2, and then this is going to equal 1. I'm going to divide by 2 and get a half. And now the question is, where does cosine equal a half? Cosine is equal to a half at pi over 3, and then in the fourth quadrant at 5 pi over 3. So we're going to take that inside stuff and set it equal to each of those two answers that we got. Okay, so every time this is the same process. And then we're going to solve for theta. So when I solve for theta, I'm adding, excuse me, is that pi over, look at me. Let's change that to what it actually says and not what I, for some reason, changed it to. So pi over 6, pi over 6, pi over 6, pi over 6. All right, when I add pi over 6 on, I get 3 theta equals pi over 2. That's where I was getting that pi over 2 from. And over here, I get 3 theta is equal to 11 pi over 6. Divide by 3. I get theta is equal to pi over 6. And theta is equal to 11 pi over 18. So those will be our first answers. And then to get the remaining ones, I need to know what the original period was, which was 2 pi over 3, because we're taking 2 pi dividing by that 3 from there. And I'm going to add that in, and I'm anticipating I'm going to get 3 times as many answers. So right now I have 2, so I should get 6 final answers. So I'm going to keep adding 2 pi over 3 on. So when I add 2 pi over 3 on that first time, I should get over here 5 pi over 6. Add it again, I should get 3 pi over 2. Okay, so 3 answers here. And then on this side, when I add 2 pi over 3 on, and if it helps you, write it with a common denominator. So that would be 12 pi over 18. So the first answer here would be 23 pi over 18. And then again, that would be 35 pi over 18. And think about what happens if I try and add another 12 pi over 18 onto that one. That's going to go outside of the 2 pi window. And the same thing over here. If I add 2 pi over 3 onto this, it's going to go outside of the window. All right, next problem. So this one, same process. So I get 3 tangent of x over 2 equals negative 3. Divide by 3. I get negative 1. And then I'm asking myself, where does tangent equal negative 1? Tangent equals negative 1 at 3 pi over 4 and 7 pi over 4. See, now this problem is a little bit different because we're not shrinking the period down. We're actually making the period larger or longer. So normal period for tangent is pi. Multiply that by 2 actually, or divide by a half, and you have a new period of 2 pi. So when I do this, I get 3 pi over 2 on this side. And on this side, I get 7 pi over 2, which is already outside of the window. But you could even think of it like this. So this is 1 pi over 2. This is 3 pi over 2. I go around again, 5 pi over 2 up here, 7 pi over 2 down here. This is actually the same as the angle on the left, just like gone around another time. So I don't want that one. And then I want to think about what will happen if I add my period of 2 pi onto the answer that I have. That will also make it go outside the window. It'll actually jump over and give you this answer on the right-hand side again. So you end up with less answers instead of more because we stretched out the period of this problem. So only this solution. All right, last one. So this one is a secant problem, but really secant is the reciprocal of cosine. So if you're like me and struggle with thinking about reciprocals all the time, you could, well, let me take a step back. You could do the reciprocal, so use cosine. But the first thing I'm actually going to do is I'm just going to subtract that 2 or that 5 from the 7 to get 2. So I get 2 on the right-hand side. Now I'm going to use the reciprocal. So I'm just going to think about cosine of that thing equal to a half. So reciprocal of both sides. Cosine is equal to a half. We actually already did this at pi over 3. and cosine is equal to 1/2 at 5 pi over 3. Now the period of this problem is 2 pi divided by 4, or pi over 2. So that's what we'll be adding on. But you can also think ahead that you're going to have 4 times as many solutions for this one. So there's going to be quite a few answers. Go ahead and add on my pi over 3's. So I get 2 pi over 3, divide by 4, and I get pi over 6. Add my pi over 3, I get 6 pi over 3, which is 2 pi. Divide by 4, I get pi over 2. And now I'm adding pi over 2 on to each of these angles, but these will be the first angles we're going to get. Okay, so let's see, add pi over 2 on to pi over 6. That's going to be 2 pi over 3. Add pi over 2 onto this angle. I'm going to get 7 pi over 6. And add 2 pi over 3 on again, and I get 5 pi over 3. If I add it one more time, it will be too big. So those are the first ones. This one's a lot easier, right? So I'm going to add pi over 2 on, I get pi. Add pi over 2 on, I get 3 pi over 2. And this angle gives a little bit of a trick answer. I add it on again, I get 2 pi. But my window to this problem does not include 2 pi. So I actually cannot include that answer, and I only get these 3. But I shouldn't say only. What I need to do, I shouldn't have circled that yet, is actually think about the fact that 2 pi, rewrite that, 2 pi is the same or equivalent to 0. So we don't want to use 2 pi. We want to use 0. So we still get those total of 8 solutions. It's just you have to go backwards to get the answer that you wanted. So 2 pi doesn't work, but 0 is the same angle within the bounds from 0 to 2 pi. So don't let yourself get tricked by that and leaving the 2 pi there or not using the 0. All right, make sure you ask any questions that you might have about this.